Hello and welcome to week 5's discussion on basic electric circuits. So today we will be doing some earlier assignment problems. So let's start with this first problem. So here we have a circuit and we need to find out the Thevenin equivalent resistance. So let's note down the circuit. There is a 3 resistance 50 ohm, 100 ohm and 200 ohms and a dependent current source which is dependent on the voltage V1 across A and B. And here we have the current sink. So how to proceed with this type of problems? So we will consider let V1 equals to 1 volts. Okay, so we need to find this current I1. So we can write this circuit as this is 1 volt set value 0.1, and now we will solve it using superposition. So we need to find out this current. So with 1 volt and get I1 as I1 as 1 by 100 50 plus 250 in parallel with 100 ohms. So today we are going through some previous problems of earlier assignments. So first we are considering this problem. This is a equivalent circuit and we need to find out the Thevenin equivalent resistance between the terminals B and A. So how to do it? We will consider a 1 volt DC voltage source across the terminals A and B, and that way we can say that this V1 is 1 volt. So we need to find out this current I1. If we can find out I1, so V1 by I1 will give me RTH, where V1 is 1 volt, so 1 by I1 will give me the R Thevenin. So that way we are proceeding. So here we have two sources, 1 volt DC voltage source and 0.1 ampere current source. So we will apply the rule of superposition and we can say 1 volt by 300 in parallel with 100. This gives us 1 by 75 ampere I1. So therefore so we have another source that is 0.1 ampere. So when we consider this 1 volt will be shorted. So here this was not present, and now this is the current sink, 0.1 amps of current source. We don't know yet, so here it will be shorted. So I need to find out I1. Okay, this will be minus 1 by 75 because minus, so the direction of current is towards the source. Here let's see what we get. So here this is shorted, so 200 ohms, 100 ohm is shorted, 200 ohm and 50 ohms. So we will apply current divider rule. So 0.1 into 200 divided by 200 plus 50, this is equals to minus I1. So I1 will be 4 by 5 into 0.1 ampere, that is 0.08 ampere. with a negative sign, of course. So I1 total is equals to 0.08 plus 1 by 75, that is a minus of that. So we will get 0.08 plus 1 by 75, that's 7 by 75. So RTH will be across B and A and not A and B, because the current is negative. So it will be 75 by 7 ohms, which is equal to 10.7 ohms. So this is the answer. This is my answer. Any doubt, or is it clear? Okay, so let's go to the next problem. Let's go to the next problem then. And there is no doubt, right? You can let me know in the comment box as well, in the chat box. No doubt. Okay, so let's go for the next question. We need to find out again the Thevenin resistance between terminals X and Y of the circuit, of this circuit. So whenever we try to find out Thevenin resistance which includes independent voltage and current sources, we will short the independent voltage sources and we will open the independent current sources. Hence the circuit becomes as follows. Since we have a current source here, we will open the current source and we will short this voltage source. So let's solve this. Ohm, 1 ohm, 2 ohm, 3 ohm, 4 ohm, 10/3 ohm, and 10 ohm. Now simplifying this circuit again, so 11 ohm is parallel with 1 ohm and then series with 2 and 3 ohms. So 11 parallel with 1 gives me 11/12. So here we can directly write, since we have 11 ohms is in parallel with 1 ohm and then the combination is in series with 2 ohms and 3 ohms. We can directly write it to be 11/12 plus 5, that gives me 71/12 ohms. 71/12 ohms, that in parallel with 4 ohms and 10 ohms so here we have 10/3 ohms. So now we can simplify it further. So we have 4 ohms and 71/12 ohms in parallel. So the parallel combination gives us some resistance value that will be in series with 10/3 ohms. So we will just add it, 3, whatever value we get, it will be in parallel with the 10 ohms. So into 10 by the resulting value or the resistance across X and Y is R Thevenin, and that is 3.638 ohms. So while finding out Thevenin resistance in circuits like this, so if we have independent sources, we need to just short the voltage sources, independent voltage sources, and open the independent current sources. But in earlier example that we saw here, since we have a dependent current source, we need to assume independent voltage source across the Thevenin terminals. We need to consider a independent voltage source of 1 volt, and then we need to proceed with the calculations, because we had a dependent source, so we cannot just open or short it directly. So this is the difference while doing the circuit analysis with the dependent sources and independent sources. So here, since we had independent sources, we could just open circuit the current source and short circuit the voltage source, and we had the Thevenin impedance resistance. We find it out to be 3.638 ohms. This is the answer. Next problem is, in the Norton equivalent circuit of the given network, the value of current source ISC is, so we need to find out this current. So we just have to do this circuit analysis, which is a very simple thing. So we have 4/6 ohms in parallel with 4 ohms, and the combination is in series with 5 ohms. So let's take the parallel combination of 4 ohms and 4/6 ohms. So that will be that is 4/7. So yeah, so I have a 5 volt independent voltage source, okay, in series with a 5 ohms, and the equivalent circuit here is 4/7 ohms. So let's find out this current I. So I equals 5 by 5 plus 4/7, this much amperes. That is 35/39 amps. Now let us consider, so this current is flowing through the 5 ohms as well as this combination where the equivalent resistance is 4/7 ohms. So let us consider that I have a current source of 35/39 ampere, and here we had 4 ohms and 4/6 ohms. So now applying the current divider rule, I can find out this current. This is the ISC. So this ISC can be obtained from the current divider rule, and that is 35/39 into the resistance across the other branch, that is 4 ohms by 4 plus 4/6. So it is 4 This is equals to 0.769 ampere. This is the answer to that question. So the Norton short circuit current that we need to find out can be found out using basic circuit, basic KVL. You can apply KVL across this loop and KCL across this node, and you can find out this ISC. Or this is a very quicker way of doing this kind of problem, that first find out the current, then consider it to be a current source, and then apply current divider rule. Okay, so we now know that the Norton equivalent current is the short circuit current, so, and that is equals to 0.769 ampere. Okay, so next question we have is find the parameters of the Thevenin equivalent circuit for the following circuit. So here we have a circuit, we need to find out the parameters, meaning the Thevenin equivalent voltage and the Thevenin equivalent resistance. So let's do it. So we need to to find out the Thevenin equivalent voltage, so we should first disconnect the load across the terminals. So here we don't have any load, so it's already disconnected. We need to find out the voltage across C and D. Let's do that. So 20 volt, we have this resistive network, so let's solve it one by one. Ohms, 4 ohms, 10 ohms, 4 and 6. Here are the terminals. So if we consider, we have 4 ohm, 10 ohm and 6 ohm in series, so the equivalent is 20 ohms in parallel with 10 ohms. So 20 in parallel with 10 gives us 20 by 3 ohms, that in series with 6 and 4, so plus 10, which gives us 50 by 3 ohms. So the current I is 20 by 50 by 3 amps, 6 by 5 ampere. That's flowing from the source. Now again we will apply that same trick and consider this to be a current source of 6 by 5 ampere, and here we have two parallel paths. One is 10 ohms and the other is of 20 ohms. So using current divider rule, I can find out this current I1 to be equal to 6 by 5 into 10 by 10 plus 20, that's 30. So that is equals to 2 by 5 ampere current that will flow through this 20 ohms. Now we need the voltage across the 10 ohms. So that is V Thevenin is equals to I1 into 10, this much volts. So that is 4 volts. And now for the finding out the Thevenin resistance, we already know it's a independent voltage source. We will short it. So if we short that, we have 6 ohms and 4 ohms in series, that will be 10 ohms. 10 ohms to 10 ohms in parallel, that will give me 5 ohm. Again 5 ohm in series with 4 ohm and 6 ohm is 15 ohm. 15 ohm in parallel with 10 ohm will give me 6 ohms. So R Thevenin is given as, so we have 10 10 5, so 5 plus 10, this parallel with 10 ohms, that gives me 6 ohms. So these are the answers. The Thevenin voltage is 4 volts, the Thevenin resistance is 6 ohms. The Thevenin voltage is calculated by disconnecting the load. We will just consider the voltage across the terminals that will arise due to the independent voltage source, and when we considering the Thevenin resistance, we will short the independent voltage source and we will compute the resistance across the terminals. So that way we obtain the Thevenin voltage to be 4 volt and Thevenin resistance to be 6 ohms. So I think there is no question till now. If you have any question, please let me know in the chat box. So let's go to the next question. Okay, so the impedance looking into nodes 1 and 2 in the given circuit. So we need to find out the impedance, that is again the Thevenin impedance, while looking into 1 and 2. These are my terminals. So again we have a dependent current source, so that is 99 IB, and IB is this current. So since we are dependent current source and we do not have any independent source here, so we need to connect an independent voltage source across 1 and 2 and then compute the current that is coming out of this one terminal. Voltage by current will be the impedance, and that is my Thevenin impedance. In similar lines with the question we saw in the first question, how we solved, in similar ways it will be solved here as well. So I leave this to you as a homework. You can try this. Also it is in the assignment, you have already done it. So yeah, it will be in the same way as the first question. So let's go to the next question again. So determine the power delivered by the 16 volt source. So here we have both independent sources, 16 volt independent voltage source, 8 ampere independent current source. So two ohms, 2 ohms, Here we have a current source. The direction is upward, 8 ampere. Here we have a voltage source of 16 volts. So again we will apply the law of superposition. So we will divide it into two circuits. First circuit being the one with the current source and the voltage source shorted. So this will be something like this. It's 8 ampere. This is 2 ohms, this is 2 ohms, and this is 2 ohms. Since we need to know the power delivered by 16 volts, we need to consider this current. So let's say this is I1. So here let's calculate what is I1. So I1 will be, so it's 8 amperes. 8 ampere will flow through the parallel combination of 2, so each will carry. So here I1 will be minus 4 ampere. So since both of them have same resistance, the current will be divided or shared equally by the two resistances. Next we will consider the 16 volt. And we will open circuit the independent current source. So this resistance will stay open and hence it won't render to the computation. So it's open. So here this is I1 again, and we have 2 ohms in series with 2 ohms. It's 4 ohms. So I1 is equals to 4 ampere. So therefore the net I1 utilizing superposition is, net I1 is minus 4 plus 4 ampere, that's 0 amps. This is the answer. Alright. Does anybody have any question? Any doubt? So if you don't have any doubt, okay, so let's move on to the next problem. Okay, so an 11 volt pulse of 10 microsecond duration is applied to a circuit shown in the figure. Assuming that the capacitor is completely discharged prior to applying the pulse, the peak value of the capacitor voltage is. So a 11 volt pulse, it is applied for 10 microsecond, is applied across these two terminals. So for that we need to see what is the response of this circuit, and from there we can say what will be the peak value of the capacitor voltage. Alright. Okay, so here we have it is alright. So let's consider this step change first. So here is a step change in this duration, so let's consider this to be 0 time period when this step change occurs. So circuit is 1 kilo ohm, here we have 10 kilo ohms, nanofarad plus minus 11 ut. Since the circuit was initially completely discharged, the capacitor, so there won't be any voltage across it, so we can directly say 11 by s in Laplace domain equals to, let's say this is my current I, so Laplace domain it will be I as function of s into 1000 and let's say this current is I1, so plus I1 is into 10 into 1000. Another equation you can write, that is the Kcl equation here, that is Is equals I1s plus 1 by s c, that is 11 into 10 to the power minus 9 this voltage, that is I1s into 10 to the power 3. So solving these equations, I1 function of s plus (9.1) into 10 to the power 11 by s so Is equals I1s 1 plus 9.1 into 10 to the power 11 by s. So Is equals I1s by s all divided by 1000. from here we can say (11/11000) s plus 9.1 into 10 to the power 14. So in time domain we can write I1t to be how much? It will be 11 by 1100 e to the power minus t pi okay, I did a mistake here. This can be further simplified in the form 11 by 9.1 into 10 to the power 14 by 11000 s by 9.1 into 10 to the power 14 plus 1. This is my tau, so I can write I1t to be 11 by 9.1 into 10 to the power 14 e to the power minus so here we know t is 10 microseconds, so from that I can find out I1 at 10 microsecond equals I think I have done some mistake here. Oh, yeah, found out the mistake. Here it will be, since it's a voltage, that into SC, so it will be admittance into the voltage, not impedance. So S into 11 into 10 to the power minus 9. it will be multiplication. So from here onwards this will change. So you can write it to be I1s into s into 11 into 10 to the power minus 5. So it will be 1 plus 11 into 10 to the power minus 5 into s so here it will be this into 1000, so into 1000 here, so you get 11 into 10 to the power minus 2 s so here we will have s into s into, here we will, let's say here we consider it to be 1 plus s into 10 to the power minus 5, 11 by 11000. So we can say it's 1 by 1000, 1 by s, sorry, minus 1 by not 1 10 to the power minus 5 by 1 plus s into 10 to the power minus 5. So my I1t is 1 by 1000, 1 minus e to the power minus t into 10 to the power 5. So here at 10 microsecond I can obtain 1 by 1000. Basically we will have t equals to 10 microsecond, so we can say it to be 1 by 1000 into 1 minus so it's basically 1. So I can write it to be I1t equals to 1 by 1000 1 minus e to the power minus, in place of t we are 10 microsecond, that is equivalent to 1. So this gives us an answer of 6.32 into 10 to the power minus 4 ampere. So my peak capacitor voltage VC peak is equal to this 6.32 into 10 to the power minus 4 into the resistance in parallel to it, that is 10k. So that is 6.32 volts. That's the answer. So at the end of the 10 microsecond, the current across this capacitor will be the maximum, and at that time the current flowing through this resistance is this value 6.32 into 10 to the minus 4. So the voltage across this resistance is same as the voltage across the capacitor. So that into the resistance value will give me the voltage across the capacitor, and hence we obtain this is the maximum voltage that will come across the capacitor, that is 6.32 volts. Alright, so thus concludes our problems session. If you have any other query or any query related to these problems, you can ask or comment on the chat box. Any question? So if you don't have any question, you can leave the session. Thank you for joining.